ecological perception in human performance. I thought I'd give just a really brief little overview of where I've been, sort of add to what Michael's just said. So I did exercise science and psychology at Vic Uni down in Melbourne in undergrad, and then moved up to Brisbane to do the PhD with Michael and also John Pebbing in Brisbane. Was there for 5 years in total, roughly, which included a bunch of sessional teaching in about half the exercise science degree units up in Brisbane with that excellent team up there. But then moved back down to Melbourne the middle of last year and started my current role with the Healthy Brain and Mind Research Centre in the Development Disability over the lifespan group. So that brings me to here, and this is a little GIF that might be familiar to a bunch of people who have seen me present before. This is an example of essentially what I'm going to be talking about today, which is exploration. And so you can see what the meerkats are doing. Obviously, they're looking around left and right. And this is sort of the broad topic of what I'm interested in is how people, not meerkats, visually perceive their environment. And in particular, when it's in a 360-degree environment, which is actually pretty much always, we need to do it by turning our head. And this is a really nice little example of what that can look like. In this case, with the meerkats, they're doing it to bring in information about their world, which for them is to perceive threats to their group. And they do that, they stand up on their back legs and look around like this. But you can imagine if we're thinking about these meerkats, what behaviours they would do if we were to take them and then put them in front of a computer and try to observe their behaviour. Would we still sort of see this kind of behaviour? Would it be similar to what they do in the natural environment? Most likely not, and that's sort of where my whole research, PhD research, comes from, is can we observe behaviours of people in their natural environment as opposed to putting them in front of computers and things like that. So this is a sort of more relevant example, I suppose, where it's actually in football, which is what my PhD was. And you can see that there's these 3 players in yellow who are all looking towards the same direction. You can see the path of this red player here that he's run from. And then in the second picture, the ball is coming across, which you can't really see, but it's around here. And these 3 players were all called out of position. No one's marking this guy here, and he goes and scores a goal. So they're not visually perceiving their world in a way that allows them to effectively function in the situation that they should be. If they were taking good notice of what's happening around them, then at least one of them would have marked that red player and tried to stop him from scoring. Like I said, my PhD was in football. If we're talking about the Healthy Brain and Mind Research Centre, I thought maybe that's not the most relevant or most interesting for everyone. And so what I decided to do is kind of take a bit of a step back and then talk a little bit less about the specifics of my PhD, but be a bit more broad in sort of and conceptual in terms of what I'd like to present today. So hopefully can discuss a bit about these 3 sort of themes that are all very central to my PhD, and hopefully give some idea about how they might be useful and how people might think about them for maybe your own research areas and just get a more broad idea of what the background that I come from. So I'm going to start off with the exploration aspect. And when I say that, I really mean it in terms of discovery. So we're exploring in order to discover what's happening around us, what's available to us. Really sort of exploring the world and discovering what is out there. And that's what I mean by exploration. And this happens at a very, very early age. So you'd all be able to think about, little infants and toddlers, some of them in your own lives. They just explore everything. And very early on, they tend to do it with a lot of touch and a lot of taste as well. So whenever there's something around them, they'll pick it up, they'll grab it, they'll move it around in their hands. And what they're trying to do is to learn about those objects and learn about those environments, what they feel like, and what they might be able to do with them. And quite often what they'll do with them when they're very young is they'll put them in their mouth, and that's another way of exploring what is offered to them in the world and trying to learn about the world. And obviously with taste, another fun little example is giving a child a lemon for the first time. they'll put it in their mouth out of curiosity. They want to explore what happens with it, and they'll get a very common response where they find out it's very sour and they're not really that into it. But that's a really important thing for learning, and they wouldn't learn that without exploring through tastes in that case. So that is maybe a bit of a weird analogy when I'm coming from a visual perception and exploration aspect, but hopefully some of that meaning is coming across, and that exploration is a thing that is really important for development in general. Another aspect of exploration that's really important to consider is that we do it for perception. So this is how we bring in information about the world. When a baby explores with their hands, they're doing it to perceive through their touch and through their taste and things what is available in the world. So they're trying to perceive what's out there. My PhD works in visual perception, so I'm most interested in the eyes, obviously. That's how we bring in visual information. But when we talk about visual perception, we can't only think about the eyes. If we want to see something that's directly in front of us, then yeah, probably we can do that with our eyes. And that's probably true for most of you right now. You can explore the computer screen just by moving your eyes and see everything that you need to. But if we want to see maybe if someone knocks at the door or if something happens behind us, then we can't just do that with our eyes. We have to use more of our body in order to perceive what's out there, and that's when head movement comes into it. And so we have to consider that we need to bring in information through our eyes, but quite often we need to move our head to orient our eyes towards things. And when we need to see in 360 degrees, that head movement becomes very, very important. And so that's also a consideration if we're thinking about exploration and visual perception. The picture here is kind of just to give an example of what that's like out in the real world when we're navigating the world and when you're crossing a road. You'll look left, right, left, or right, left, right, whatever it's meant to be. I don't know how I learned it, but you look both ways when you go to cross a road. That's for safety, and you do that by moving your head as well as your eyes. And the last thing to do with exploration that I want to sort of cover is that exploration is an action, exploration as action, and it's also for action. And so we can see in this image that there's a whole bunch of players here, and they're all exploring, they're all looking towards the ball, except for that one player in the middle who I think is in possession of the ball, or most likely to be in possession of the ball. And she's actually looking away. She's not looking at the ball, she's looking elsewhere to try and find someone to pass to. And so that her visual perception, her exploration, is supporting her future actions, what she's going to do with the ball. And so exploration is really important for us to be able to act in the world. But also here we need to consider that exploration is an action. So moving the head, that is an action in itself. Moving the eyes, that is an action in itself. And so we get this relationship between perception and action that really you can't separate. They support each other. And that's something that we need to consider when we are investigating both actions and perception. So if we want to know something about how people perceive, we need to think about their actions. If we want to know something about how people act, we need to think about how they perceive the world. And so that's a big part of this exploration concept, is that we really can't separate perception and action if we want to get anything meaningful about how people behave. Which brings me nicely into ecological design. So this idea of perception and action being coupled together and not being able to separate them is a big part of what ecological design is. And when we're talking about ecological design, we're talking about the relationship between living things and their environments. Okay, and so as an example to start to explain this, we have individuals and they're always situated in some sort of environment, and we really can't separate these two either. In the same way that we can't separate perception and action, when we're thinking about people, we need to think about the environment that they live in and they operate in, and if we're going to understand anything about those individuals, we also need to understand about their environment. But also with this individual environment connection, we always have certain tasks that we're trying to do. And so this is also a really important consideration when we're thinking about how we understand people and in their world. So in this example, maybe we've got this individual and they want to get a good view of out in the horizon, they've climbed up to this mountain and they want to see what's happening out there. And that's their task at this time. They want to get a better view. And they've made really good use of the environment to do that. They've decided to climb up on the fence so they can get a better vantage point and see what's out there in the world. If we change something about the environment, that's going to change the way that this individual completes that task. Or if maybe the individual changes the task that they want to do, that they might use the environment in a different way. If we put a different individual in this situation, they might complete the task in a completely different way themselves. And so these three aspects are all interrelated and they all influence each other in a way that's really important and needs to be considered when we're doing research with people. This is some actual data from my PhD. It's from my systematic review, which was the first study of my PhD. And I want to use this to sort of explain that point a bit further about the importance of considering the environment and the task when we want to understand behaviours. So this is some data relating to the experimental designs that have been used in the past to investigate visual exploration in football, and the methods that have been done to do this. So this experimental setting column on the left, that's one that was created by me in the PhD. It's just sort of trying to categorise different designs into something that's a bit more easy to understand. We've got the movement that was allowed. So this is just in general how constrained the participants were during trials, how much they were allowed to move, whether they had to sort of sit or stand in a certain position, or if they were allowed to move around freely and quite naturally. The visual environment refers to the type of visual stimulus that was presented to participants. So we had things like static images or videos of situations, or point light displays where you just sort of have an indication of where joints are, but that's just dots and that's all the information you get. All the way through to live action, so someone actually taking a penalty kick, because it's football and so it's a soccer related thing. And then the required response, this is the response that the participants needed to give in order to respond to the stimulus. So this ranged from pressing a button or verbally saying something about their response to some quite limited movement, so just sort of taking a single step in a certain direction, all the way through to something that we're calling representative, so they're actually moving in the way that they would in a natural environment. So they're actually diving to try and stop a penalty shot, for example. There was 38 studies in total, and we can see that, and you'll notice these percentages don't quite add up. That's because the other 10% used a combination of these different experimental settings. But you can see that 2/3 of them used some sort of image, video, or point light display as the stimulus. So something very static, everything already directly in front of the participants, not really similar to the environments that soccer players compete in naturally. That was 2/3 of the studies. And about half of the studies didn't allow a natural response. So when they were needed to respond to some sort of stimulus, they were either pressing buttons or just taking a single step. So again, the solution to the problems is not really very representative of what we actually want to investigate, the actual behaviours of the real world. We can see that we've got, there was 11 studies that used this controlled in situ one, where they're actually responding to a real person. They're allowed to move freely and their response is very representative. Okay, so it's pretty close to the real thing. I think it's important to note that 8 of these were a penalty kick situation, which is it's an important part of the game, but it's in terms of total playing time and things like that, it's quite rare. So there's a lot of the game that's not being represented by these studies. And you'll also notice that there was no studies that looked at open match play. So no studies that actually had the actual individuals in their natural environment completing the tasks that they complete in actual competitive play. There's a slight little asterisk on that, in that this was looking at studies that use technology to measure visual exploration. There was a couple of studies that had people watch video footage of games and manually count head movements, which was really important work, but it was, it's fairly prone to error potentially, not necessarily particularly accurate. So it was out there, but in terms of having really high quality, accurate data, there was basically nothing out there at the time. So with all this, you can start to see most likely, and probably the reason for the studies being done in the way that they were, is that there's lots of challenges with ecological design. If we want to understand the relationship between individuals and their environment, we need to study them in their natural environment, but that is quite challenging. And when you think about a sport like football, there's a lot going on. It's very unpredictable. It can be quite a challenge to get access to groups of players that are going to let you do that. You can't necessarily use a lot of lab equipment that we might be used to. And so there's all these challenges that you need to overcome in order to get good data. And so this was part of the problem that we needed to sort of overcome in my PhD. And to give an example about why it was really important to overcome these challenges, there was a really nice study by Matt Dix and colleagues in 2010, where they looked at the visual gaze behaviours of goalkeepers in penalty kick situations. So this is one of those studies that was in that table. And it's one of the ones that was across a few different designs, because they had goalkeepers in penalty kick situations, but they presented either videos or real life penalty kicks, and they also had them do a few different types of response. So they had, I think, a button press, sort of a verbal response, or actually diving to save the ball. And this was a really good study because it allowed us to understand the differences between these different experimental designs. And what they found is that when they allowed players to behave in the most natural way, so responding to an actual penalty kicker and actually diving to save the ball, their visual perception behaviours, their eye movements, were very different to when they were not physically responding naturally, or not responding to the visual stimulus that they would normally experience. And this is their visual behaviour before they need to move. And so just the nature of what they're seeing and the idea that they know if they can move naturally or not has influenced their visual perception before they need to move. And so to me that says, okay, well, if they're going to behave differently based on if they're allowed to move or not, we really need to let them move naturally. We need them to move naturally in their natural environment, which is on the football pitch. And so this was the challenge we needed to overcome. It comes with some interesting limitations potentially, but I think my view is that that's worth it in order to really see the natural behaviours of people and be confident that those are the behaviours that people actually use. And this is where technology comes in. So I think a really good solution to overcoming these challenges of ecological design is through the use of technology. And so that's what I'm sort of going to briefly cover about some ideas around that and how we overcame it in my PhD. So technology for eye movement has been around for quite a while. So eye tracking goggles now, glasses are quite common, but eye tracking has been around for quite a while. There was sort of big systems that were sort of size of huge computers, and people had to sit with their head braced in order to get accurate data. It was very early on, and we've come a long way since then. But the technology for tracking the movement of the eyes, while it's come a long way, still isn't necessarily at a point where we can use it in sort of open natural environments. I think it's very close now, and some of that research is starting to come out. But when we think about settings that are typically outdoors and it's quite bright and there's a lot of contact going on, it's sort of not necessarily the best situation to be able to use eye tracking technology. The studies that are starting to come out, they're super interesting. There's a lot of interesting things coming out of them, but they're very small sample sizes and very labour intensive to be able to process that data, which sort of makes it a bit challenging to think about what the practical use of that is if we're thinking about applying that to teams of players, for example. Eye movement technology is also being built into a lot of virtual reality and augmented reality systems, which allows the measurement of gaze in virtual environments, which could open up some really interesting opportunities in the future where we can present information that visually is very, very similar to the real world, but we can sort of have a bit more control over what that information is that's presented. So then there's potentially technology for head movement. And so as you would have picked up by now, that was my interest, is in the head movement aspect of visual exploration. Because when we're in a 360-degree environment like football, we need to move our head, and that head movement becomes really, really important. There was a lack of research in head movement in football, I think primarily because there wasn't a good way of quantifying it. So like I mentioned, there was some research where people would manually count based on video footage, which has its own challenges. But technology can be used for collecting this data, and that was a big part of what we did in my PhD to overcome that challenge. So the solution was to use inertial measurement units, and that's an example of one on the left there. And the picture on the right, you might be able to see the player in blue is wearing a black headband, and secured in the back of that is an inertial measurement unit, which is collecting data about his head movement throughout the game. So what this technology does is it combines accelerometers, gyroscopes, and magnetometers, which measure acceleration, angular velocity, and magnetic field, and that allows them to give information about the orientation of the sensor at a really high capture frequency. So at any point in time, we can know what direction the sensor is pointing, and we can use that information to run it through some algorithms and get a really good understanding about when players are turning their head, how big those head turns are, how often they're happening, all those sorts of information. This technology isn't actually particularly novel. It's in all of your mobile phones. It's what allows your phone to know if it's in landscape or portrait mode. It's also been used for years to help fly planes and things like that. So it's technology that's incredibly common, but it just hadn't been used in this way before. What we're able to do with this data is to also synchronize it with GPS data and video data, which allowed us to add a lot of context to it to get a better understanding of what's happening in terms of the task. So we can understand where players were on the pitch, what they were doing at the time when they're looking around, those sorts of things, which allowed us to really get a good understanding of the individual players, their environment that they're in, and the tasks that they were completing. And it was the technology that really allowed us to do that successfully. Yeah. So that's where I sort of sit right in the middle there of those three themes, and hopefully that's been a useful bit of information to help get an understanding of where I've come from, and hopefully it's sort of maybe made you think about some of your own research ideas and how you go about things. I can understand with potentially some of the people in the audience that it might seem like it's not applicable at all. There's certain limitations that a lot of us have to sit within, but potentially it might get some ideas flowing around how we might be able to be more ecological in the way that we're investigating things, and think about our research in maybe a slightly different way. But yeah, that's me. If anyone has any questions, then I would love to hear them.